Let us solve a question on utility function. If the utility function of a consumer is u is a function of x1 and x2, which is being given as is e raised power x1 times x2. x1 and x2 are the two goods. Price of good x1 and x2 are 2 and 10 respectively. Income of the consumer is $20. We need to find out the optimum commodity purchases by the consumer. Okay, so we are being given the utility function u is equal to e raised power x1 times x2. Okay, price of good x1, let's denote it by p1, is being given as $2. Price of good 2 is $10, and income of the consumer is equal to $20. Okay, we need to find out the optimal consumption bundle. Okay, so what we want to do, if we have the graph of this problem, so we have x1 on the horizontal axis, x2 on the vertical axis. Okay, we are being given the budget line. Okay, given this budget line, we want to reach to the highest possible indifference curve. That means uh, our indifference curve at optimum should be tangent to the budget line. That means this is our indifference curve, this is our budget line. Optimum bundle will lie at a point where indifference curve is tangent to the budget line, and corresponding to this we need to find out the value of x1 and x2. Okay, so our question reduces to, that means we want to maximize our utility function u is equal to e to the power x1 times x2, subject to the budget constraint. What is budget constraint? Simple, price of, that is p1 times x1 plus p2 times x2 should be equal to the total income of the consumer. p1 is 2, so we have 2x1 plus 10x2 should be equal to 20. Okay, so we want to maximize this utility subject to this budget constraint. Given this budget constraint, we want to maximize our utility. That means we want to reach to the highest possible indifference curve. The condition is simple for optimization or optimum. That is, our MRS should be equal to the ratio of the prices. Okay, P1 upon P2. MRS is simply slope of indifference curve, and this ratio denotes the slope of SLOPE, slope of budget line. Okay, at optimum, slope of indifference curve should be equal to the slope of budget line. Now MRS is simply the marginal utility of good 1 upon marginal utility of good 2 should be equal to P1 upon P2. Marginal utility of good 1 means the partial derivative of utility function with respect to x1, and marginal utility of good 2 means the partial derivative of utility function with respect to good x2 should be equal to p1 upon p2. Okay, now du upon dx1 means the partial derivative of this utility function with respect to x1. Okay, now what is derivative of e to the power nx? It is simply e to the power nx times n. Okay, now we have e to the power x1 x2, e to the power x1 x2. If we take partial derivative with respect to x1, what will be the derivative? Simply we have e to the power x1 x2. Okay, to this we multiply. Okay, what is then the derivative of x1? It is 1, so we will be left with x2 only. Simple. Here in place of n we have x2. N is here a constant because we are taking partial derivative with respect to x1. Okay, so first e to the power x1 times x2, its derivative is first this function which is being given, to this we multiply this x2. Okay, that means we differentiate exponent with respect to x1. Derivative of x1 is 1, and we are left with x2, and we multiply it with this x2. So du upon dx1 means we will get e to the power x1 times x2, and this x2, okay, which is multiplied, divided by du upon dx2. Again, its derivative with respect to x2 will be e to the power x1 x2 and multiply and take the derivative of x2 here. Okay, so derivative of x2 is 1, so we are left with x1 here. Okay, should be equal to p1 upon p2. P1 is 2, p2 is 10. Okay, which implies this stuff gets cancelled. 2 ones are 2 5s are, we are left with x2 upon x1 is equal to 1 upon 5, which implies x2 is equal to 1 upon 5 x1. Simply plug this value into the budget constraint here. Okay, that means 2x1 plus, in place of x2, let me write it here. We have x2 is 1 upon 5, 1 upon 5 x1 should be equal to 20. So 5 ones are 5 twos are, so we have 2x1 plus 2x1, this is 4x1 is equal to 20, which implies x1 is equal to 20 upon 4, which is 5. We got the value of x1 is equal to 5. To find the value of x2, plug the value of x1 is equal to 5 here. Okay, that means our x2 will be equal to 1 upon 5. The value of x1 is 5, so x2 will be equal to 1. Okay, so the optimum consumption bundle will be x1 will be equal to 1 and x2 will be equal to 5. Okay, so remember here, and let me explain it again. How do we take derivative here? So if we have e to the power x1 times x2, okay, its derivative du upon dx1 is equal to derivative of this, exponential function is equal to the exponential function given, that means e to the power x1 times x2. First we write the exponential function which is being given, times, we see what is the exponent here, since we are taking the derivative with respect to x1. Okay, or we can use simply the chain rule, that means d upon dx1 of x1 x2. Okay, so we have e to the power x1 x2. What is the derivative of x1? It is 1, so we are left with x2. This is how we differentiate the exponential function.